Good evening, technical directors, professors, and colleagues. Welcome to the 2021 ELECOMP Virtual Summit. We are Team Vicor, and our Capstone project is a probe interface hardware checker. Our technical directors that guided and mentored us throughout the semester were Alfred Binder, Product Engineering Manager, Nathan Shake, Associate Test Engineer in URI Class of 2020, and finally Daniel Hartnett, Associate Test Engineer, URI Class of 2021. The designers that worked on this project included myself, Boston Lee, Electrical Engineering, and Giuliano Biondi, Computer Engineering. The company behind this project is Vicor, incorporated in 1981 with the main branch located in Andover, Mass, and subsidiary branch in Lincoln, Rhode Island, as well as overseas. Vicor has established itself as a dependable and recognized leader in the world for power supply in semiconductors and power modulation. Some projects for power supply in the market include telecommunications, transportation, defense, computing, and many more. The project motivation for the company is that it will save time and resources due to any faults and errors being more easily found with the hardware checker. It ensures all the components off the probe board are actively working efficiently and effectively as intended, which decreases development time for similar cards and shift the focus on creating higher quality products as opposed to errors. The anticipated best outcome is for the team to create multiple hardware checkers that will be able to rigorously test each of their intended probe cards in order to confirm hardware functionality and completeness. On the left, the picture is of resistor rings, and they are typically placed directly onto the probe board located on the right of the screen to reduce or eliminate any current leakage. The technical accomplishments for the semester included the execution of 3 hardware checkers. Our best anticipated outcome was achieved with the completion of the PO12s, PO52s, and the PO69. Code was designed for the PO12, PO52, and PO69. However, only the PO12 was tested on the designated probe card due to the testing room being fully occupied. The economic impact the hardware checker has on the company is higher rate of production of chips with good functionality and higher quality. The hardware checkers ensure the caliber of the chips and increases the productivity rate for more of them to be pushed out into the market. With more chips in the market, more electronic devices can be made for the public, and Vicor's reputation and reliability would increase to companies and stockholders. This is a flowchart and it describes the general usage of the hardware checker. First, you set up the probe card, then add the resistor ring. After, you compile, run the code, and create it for the specified hardware checker. Following running the code, the user will be given either no errors, which establishes everything is working correctly, or errors where debugging would commence. However, if there are no errors, the user would have to run the probe card without resistor rings to make sure the card is good. If the errors are presented with the removal of the resistor ring, then debugging would occur. My technical accomplishments during the semester was creating successful hardware checkers in the PO12s and PO69s. From the creation of these checkers, I was able to obtain the skills of reading schematics using Eagle test programs, which is used for coding with on-demand bugging, as well as gain knowledge in the testing room with the ability to set up probe cards and attach any connectors needed. Here we can see the schematic for the main page of the PO69. It includes matrices, APUs, drivers, and grounds. On this slide, we take a closer look of the site off the PO69 main page, in this case, site 1, in the portion of the code corresponding with the test where voltage would be forced. We first start the test by turning off the matrix, C-bit K42, and then force voltage to expect 1000 UA. In order to get the value, we would start by closing C-bit K26, and after open the relay and matrix back up to ensure the current reading is correct and get 0 UA, since no voltage should be coming through. To understand the ABO, some of the key elements needed are communication with the technical directors, whether it be professional or for personal reasons, understanding the code and schematics and how to apply them with the usage of the Eagle test systems for certain creations and completions of many more hardware checkers in the near future. With all this in mind, I'd like to introduce my partner, Giuliano Biondi, and he'll be leading us to the finish line for the remainder of the presentation.
Again, here is our flowchart that shows the process of how the hardware checker would work in a given scenario. In the beginning of the semester, my main priority revolved around receiving already completed hardware checkers, such as the PO12, and walking through the test code and seeing what components or path it tests. This allows me to understand exactly how the hardware checker works and the reasoning behind it. After I grasped a good understanding of the hardware checker, I got the okay to move on to the P052 probe checker, where my task involved creating the whole hardware checker from scratch. On this slide is the main page of the P052 schematic. Every path, pin, resistor, and capacitor that will eventually be tested throughout the code. On this page, there are net labels such as OC timer, which when creating tests for the timing page, we'd have to be aware of these labels to follow the paths onto the next page of the schematic. The picture of code that's job is to test an individual pin of the P052 is shown here on the right. The test involves using an APU or MAT as a reference point to send a volt and measure current across the designated pathway. GP_OC on the first line of the code lets us know what APU we will be using as a reference point, which you can see is on the highlighted line is marked APU 5. APU_FV lets the test know we are forcing voltage. In the first line of the test, we send 4.7 volts through the path because of the 4.7K ohm resistor. This easily is calculated, so the estimated current would be 1,000 microamps. This is a simple setup of testing hardware at Vicor at wafer level. The cables come out of the tester as seen on the right and are then connected to their specific locations on the probe card. The cables include timing cord A and timing cord B, which allow us to create tests on the timing page of the schematic. Some key technical accomplishments that I will personally make would be using my skills and newly acquired knowledge on hardware checkers to create different types of probe cards that may involve different combinations of components. Also, if we have more time, I am hoping to be able to move on to possibly creating a different type of checker instead for the cables and the Eagle test system itself. Throughout next semester, our main team focus will be creating more hardware checkers that differ from the previous P052 and P069s that we completed. If our technical directors believe we understand the hardware checkers thoroughly, we'll be able to confidently move on to new tasks such as a cable checker program and an internal Eagle test system checker. Moving on to risks, there are many events and risks that can halt our progress with Vicor. With COVID cases on the rise, if one of us gets sick or exposed to someone who's had COVID, that could prevent us from meeting with our TDs in person, which have proved to be very beneficial. Bugs in our code that we cannot find or figure out can also slow our progress down, as a good amount of time would be wasted trying to find errors in our codes. As a conclusion, I would like to thank our technical directors and Dr. Sunak. Thank you for this opportunity and being there for us to excel our skills and putting our knowledge to the test. Thank you.